Welcome to our second oscilloscope video. We'll continue with our basic overview of the Tektronix MDO 3000 series oscilloscope, specifically model MDO 3104. This is a 4-channel digital storage oscilloscope, and in a later video we'll be looking at some of the implications of MDO, which stands for Mixed Domain Oscilloscope. First, we'll do some elementary measurements. Later on, in a future video, we'll look at the arbitrary function generator and methods for saving waveforms and networking to a remote computer. But first, this simple exercise. This probe has been connected to a 9-volt battery, and since the 9-volt battery is not referenced to ground, there's no possibility of a hazardous fault current. We simply connect the probe using the convenient hook tip and ground reference lead. Notice that there's no meaningful display at present. Well, that's easily remedied. Press auto set. And there it is, a horizontal yellow line. Yellow is the color for channel 1. And it's horizontal, indicating that it's DC, and it's just short of the second division up from the x-axis, meaning it's just about 9 volts. The number of volts per division is shown in the lower left corner, and as you can see, it's 5 volts per division. On the left side of the screen are ticks, and these ticks are 1 volt divisions, subdivisions, between the main divisions in the display. Now, if we want to get a more accurate measurement, we'll press DVM. First measure, then DVM, and multipurpose knob A brings us down to DC. And we have a nice uniform 8.9 volts DC. And if we use multipurpose A to go down to frequency, we'll see that the frequency is not applicable since it's DC. Now we've reversed the connection on the battery, and the DC voltage is down below the x-axis. Well, that makes sense. Now we're going to do a little more intricate exercise. What we're going to do is measure the utility voltage at this building. So we'll take out this probe, and put in the other one, which is all set up to measure the utility voltage. And you notice we do not have a meaningful display. So let's push auto set, and there we have it, a nice clean sine wave. The vertical position and scale can be changed by adjusting the 2 knobs at the channel input. So we're changing the position, and we'll change the scale. And anytime you get lost and you want to go back, you press default setup and you press auto set, and you're back to the 60 Hertz sine wave. The triggering level can be changed by turning the small knob next to the keypad. The horizontal line that is now moving upward is the triggering level. If this triggering level goes above the peak voltage, triggering is lost. We're back in the early 1940s, before Howard Vollum and Jack Murdoch launched a new era in electronic measurement by introducing triggering in the brand new Tektronix Model 511 oscilloscope. Thanks for watching. In our next video, we'll check out the built-in function generator, a useful option in the Tektronix MDO 3104.